Hi, welcome to this tutorial at Supercomputing 2017, entitled Expressing Heterogeneous Parallelism in C++ with Intel Threading Building Blocks, that will be delivered on Monday, November 13th from 8:30 a.m. till noon by James Reinders, Pablo Rebol, Jim Cowney, and Rafael Asenjo. This tutorial addresses heterogeneous hardware and software, and it is motivated by the need of reducing energy consumption in all segments of computing devices, from supercomputers to smartphones and wearables, going through desktops and laptops. To that end, accelerators like GPU and FPGA came to rescue some years ago and now can be found tightly coupled to the CPU inside a single chip. Just two examples in the desktop and laptop domains are the latest Intel Kaby Lake processor and this AMD Accelerated Processing Unit, where around 50% of the transistors are devoted to the GPU. But also in the emerging mobile segment, you can find quite heterogeneous architecture, like this Kirin chip that is at the heart of the Huawei Mate 9 and that features a big little CPU along with the latest ARM Mali GPU. And if you think this is not enough heterogeneity, look at this even more complex chip that includes two CPUs, one GPU, and an FPGA. So now the question is how to fully exploit this architecture and not die trying. In order to introduce you into this exciting topic and help you coding efficient heterogeneous codes in a productive way, we have put together the following material. Part 1 first covers important hardware aspects of common heterogeneous architectures. We will briefly discuss the underlying architecture of some heterogeneous chips composed of multicores plus GPU and multicores plus FPGA. We then move to the software side of the tutorial, where different heterogeneous programming models will be introduced, paying more attention to those that are aimed at exploiting several devices at the same time. In parts 2 and 3, we will focus on Intel TBB. First, covering the basic of the TBB library and its relevance to HPC and heterogeneous computing, to later present deeper coverage of the new features included for heterogeneous programming. Attendees can take part in hands-on exercises to create a small example and evolve it from a sequential implementation to a heterogeneous one that runs on both the host and the accelerator. Finally, in part 4, we will discuss ongoing research in developing hybrid schedulers for parallel patterns such as pipeline and parallel for. We hope you find this tutorial interesting and enriching, so please join us at Supercomputing 2017 this coming November 13th.